reference angles. The values of trig functions of angles greater than 90 degrees or less than 0 degrees. So we're talking about angles that are not in the first quadrant. They can be determined from their values at corresponding acute angles, and these corresponding acute angles are called reference angles. So let's define this reference angle concept that we've been working with for a while. Let theta be an angle in standard position. That means its initial side is on the positive x-axis. Its reference angle, theta prime, is formed by the terminal side of theta and the x-axis. So important. Look to the terminal side of your angle theta and the x-axis, and that will be the reference angle. By the way, the reference angle, theta prime, is always positive, and it's an acute angle. So we can say that theta prime is between 0 and 90 degrees as well. So where are these reference angles? Well, it depends which quadrant you're in. Here is a quadrant 1 angle, quadrant 2 angle, quadrant 3 angle, quadrant 4 angle. They're all in standard position because you can see that one of their sides, the initial side, is always on the positive x-axis. So I'm drawing my initial side there, and in this case, here's my terminal side, my terminal side, my terminal side, and my terminal side. I'm going to open these angles counterclockwise or positive. So here is theta. Here in the second quadrant is theta. Here in the third quadrant is theta. And here in the fourth quadrant is theta. Now, the reference angle, which is, again, always positive and always acute between 0 and 90 degrees, is going to be between the terminal side of our angle and the x-axis. That was our definition. Here's the terminal side of our angle and the x-axis. You can see in quadrant 1, theta prime is actually equal to theta. So we really don't have to worry about that situation. It's not any different. In quadrant 2, we've got this obtuse angle, and between the terminal side of our angle theta and the x-axis, you see this little wedge of cheese there, is theta prime. Notice, if we're going to find the trig ratios for this angle, we'll put our eyeballs looking through theta prime, and we'll use theta prime to find the trig ratios for theta. That's the key concept. We use theta prime to find the ratios for theta. Here is theta prime in quadrant 3. Notice, I'm just following my definition. It's between the terminal side of the angle theta and the x-axis. And again, if we're going to find the trig ratios of theta, we are going to look through theta prime and use the ratios from theta prime. Lastly, in quadrant 4, we have this huge theta angle, and stuck between the terminal side of theta and the x-axis, we've got this acute angle, theta prime. We're going to put our eyeballs looking through theta prime and making our triangles that way. We'll use theta prime to find the ratios for theta.